Section 5, Naive Bayes algorithm. Hello. Before running naive Bayes, I want to say a few words about it. Naive Bayes works best when combining a lot of independent probabilities, or close to independent. When I saw the noisy variable interaction graphs when we did a SPLOM plot, I thought Bayes might work well on this dataset. However, Bayes must use all probabilities, so it's vulnerable to bad variables, and our insulin and skin fold variables were about half and a third missing, respectively, and replaced by medians. So it might be worth seeing if Bayes would work better without them. To test this, we'll have to compare on the training set, or else on a validation set carved out of the training set. Also, naive Bayes supports leave one out validation, effectively 768-fold cross-validation. This is because mathematically, it's easy to remove the effect of one instance in Bayes' product, so we just compute the product of all 768 instances, training and test together, and then in turn remove each point and predict for it from the other 767. R's caret package features leave one out as an option. However, in our case, we would need to recompute the median of non-missing values for each patient, which would mean a little custom code, and it would remove the parallelism with the other algorithms. So I'll continue with the same Pima train and Pima test sets we've been using. Also, I'll show you an automatic way to do confusion matrices.